Sugar. What is it? What does it do? What doesn't it do? And what are the implications on health, specifically obesity? There has been considerable debate about sugar's role in the obesity epidemic. So I believed sugar was independently fattening. I did not believe that the same thing would happen if you give 100 calories from fat. So without further ado, let's get into sugar and why I don't believe it caused the obesity crisis. What's up? Welcome back to the Dr. Layne Norton podcast. I am your host, Layne Norton, and today we are going to be talking about sugar. What is it? What does it do? What doesn't it do? And what are the implications on health, specifically obesity? Now, sugar has been a hot topic over the past probably decade or two. You've probably heard in the news that, for example, in the 1970s, 80s, when the food guide pyramid came out, they told us to eat more sugar and they promoted sugar and they told us to eat less fat and everybody got sicker. They didn't tell us to eat more sugar. The food guide pyramid actually said reduce consumption or minimize consumption of added sugars. It did say to eat a lot of fruits and vegetables. It did focus on whole grains and complex carbohydrates and kind of meats, fruits and vegetables, moderation. And at the top you had like sugars and added oils, which are supposed to be used kind of sparingly. And the food guide pyramid also said, do not overconsume calories and make sure you are active. And somehow people seem to think that since we ate more carbohydrates, that means that we followed the food guide pyramid. No, we did not. We did not increase our physical activity. We did not reduce our calories. We did increase our carbohydrate consumption along with the consumption of fats and added oils. And yes, we increased our sugar consumption. Now, there has been considerable debate about sugar's role in the obesity epidemic, along with the role of dietary fats and pretty much every other nutrient you can think of. Now, when it comes to sugar, I've had kind of a unique personal arc in terms of my beliefs on sugar, which I will share with you during this episode. But I think you're going to be pretty surprised by a lot of the data that I'm going to cite here. Some of you, it may make you pretty angry. Some of you may not care, and some of you may pump your fist. I don't know. But please keep in mind, I am just the messenger. I'm just conveying data. And I will also address concerns about industry funding and whatnot. And I think if I can just address those now, one of the big news hits a few years ago was that the sugar industry paid scientists to tell people that sugar wasn't bad for you and promote sugar. I don't know the specific story, but I think one of the things to keep in mind is that research requires money. I know it's a very unfortunate consequence of existence, but scientists need to be paid for their time. They cannot feed their families with well wishes and good vibes. Additionally, the analysis, the conducting of the study, the instruments and equipment used to analyze and collect data all cost a lot of money. And that's not even including the research subjects themselves. If you are really trying to do a highly controlled feeding study, a lot of times you have to pay people in order to get them to actually follow what you want them to follow. You have essentially two options when procuring funding for research that you would like to conduct. Three options, one of which never happens, which is self-funding it. So if you are a billionaire scientist, you can self-fund your own research. This is very, very rare. And even when it happens, it's usually not done in a vacuum. I'm thinking of my friends, Brett Contreras and Menno Henselmans. They have actually self-funded quite a bit of research out there on resistance training. And they still had to go through an existing lab because they don't have their own lab set up. And I believe they spent like $80,000 on an experiment. And that wasn't even buying their own lab equipment or paying subjects. That was just to fund a study to pay the principal investigator, the graduate students to conduct this study. And all the equipment they'd need to do it. 80 grand. And I know 80 grand sounds like a lot of money. It is a full year's salary for, people who are frankly upper middle class. But when it comes to research, it is not that much money. And if you wanted to fully equip a lab for good nutritional science research, depending on what you're doing research on, I mean, some of these pieces of equipment can easily go into the hundreds of thousands of dollars, like gas chromatography, mass spectroscopy, HPLC, high pressure liquid chromatography. And then you have things like massive freezers, like -80 freezers that are very expensive to operate because you need a really, really cold freezer to basically metabolically inertly freeze things. All this stuff costs money. So to really trip out a lab and then also fund the research in the lab, recruit subjects, pay people to conduct the research, because it's very difficult to just do a research study by yourself unless that's all you do with your life. And even then it's probably impossible in a lot of cases. So it costs money. And in most cases, if you wanted to fully trip out a lab, equipment, analysis, I mean, you're talking millions and millions of dollars, which quite frankly, most of the people who have the wherewithal to make that amount of money aren't doing it being scientists, to be quite honest with you. So that's kind of the backstory. So you've got that option, which isn't really an option. You've got government funding, which is very, very difficult to get and is getting more difficult to get based on current policies that are being put in place to limit government funding of scientific research. Then you also have industry funding. Now, industry funding is probably one of the most common, and that comes with the downside of introducing potential bias. But a lot of it depends on how the industry is funding the research. And I'll be quite clear, coming into this episode, you might be surprised to learn that my research was funded by the National Dairy Council, the Egg Nutrition Board, and the National Cattlemen's Beef Association. Those are three funding lobbies that exist in opposition to grains and sugar. Okay? If you're telling people to eat more grains and sugar, they're eating less protein. Okay? So my research, I got paid by people who wanted to show that protein was good and carbohydrates were bad. All right? So please just keep that in mind when you're thinking about my personal bias with this. There are different types of industry funding, and a lot of it depends on the contracts and how you get it. In the case of the funding we received, there was no restrictions on publications. So if we found something that they didn't like, they couldn't stop us from publishing it. And in fact, I just read something that was funded by the National Cattlemen's Beef Association that was a study looking at vegan meals versus omnivore meals, which didn't really find a difference in rates of myofibrillar protein synthesis. It still got published. Okay, even though I am sure the NCBA wanted it to show that omnivore meals were superior. Now, I'm not going to get into plant versus animal-based diets. That's a whole different discussion. My point is, a lot of these industry fundings don't put restrictions on what can be published. Some do, but they're usually like supplement companies or, companies who are going to really small research labs and they have more leverage. Thankfully, I was at a really, really good lab in a really, really good department. And so we had a lot of leverage in terms of what we could ask for. And it's important to point out that if you receive funding, you have to disclose that in your scientific paper. Otherwise, you can have a lot of really bad things happen to you. So if it's funded by something, you're going to see it in the paper and you can kind of make your determination from there. Additionally, I think a lot of people have the idea that if research is influenced by funding, it's the scientists are just making stuff up. And while complete fabrications of data do happen, it is pretty rare. What is much more common is finagling statistics, setting things up in a way to either show a difference or show no difference based on like what you do. A good example would be if I want to show no difference between a vegan meal and a omnivore meal, even though this is opposite of what happened. But if I want to show no difference, I could set up a high protein meal for both, because at enough total protein intake, We do know that plant-based sources of protein will equally stimulate muscle protein synthesis at a high enough total level of protein. So if I wanted to set something up to show that there's no difference, I could do that. If I wanted to set up something to show a difference, I could do that too. I could drop the protein down at the meal. I could get it closer to that leucine threshold, 10 to 20 grams of protein, and I'd probably show a difference. It happens less often that data is completely fabricated. And almost any time I've seen the headline of a research study where I go, it doesn't really jive with what I know to be true. And I've gone in and actually read the full study. I've read the paper. I've read the methods, the results. I go, oh, okay, I see why they found that. Because I can pick it apart in the methods and results. But it's hard for the average person to do that. All that to say, it is unlikely that many of these scientists just went, up, sugar is good for you, because they got handed money for doing nothing from some of these companies. What's more likely is some of this bias that I talked about. It doesn't make it okay, but that is also why replication is the mother of all science. That is why we don't get hung up on individual research studies. We look at the consensus of the data. How consistent is the effect? Is it not just one study? Is it multiple studies? Is it in multiple different populations? Is it consistent over the course of time, over different countries, in different labs? If we see those consistencies, then we can be pretty comfortable that what we're seeing is in fact the truth. I'll give you one more thing before we really get into digging into sugar. I think a lot of people believe that you can just pay scientists and they'll say whatever. And of course, are there unscrupulous scientists out there? Yes. I have met some of them. I have worked with some of them previously. Don't work with them anymore. But I've worked with some of them previously. And yes, I have seen that. But these people typically get found out. And in fact, the people that I knew to be unscrupulous did get found out. In some ways, I contributed to that. I don't want to get into the nuts and bolts of that, but in some ways, I contributed to people finding out the truth. Because if something is going to remain a secret for a long time, like somebody making up data, it's not just them. They're going to have a bunch of other people involved in it. And eventually you're going to run up to somebody who can't be bought off or who can't be paid off. It's like some of these folks out here, they'll tell you, we found a cure for cancer and the scientists are hiding it because the government or big pharma or whoever wants to control the people and make money. Okay, here's the problem with that. You'd have to have thousands and thousands of people in on the same scam or conspiracy rather. And you don't think any of those people have people in their family that they love who have been affected by cancer, who are dying of cancer or have died of cancer? Do you really think there's an amount of money that you can pay every single one of those people for them to be quiet? No. My friend Joseph Zundel, he got into cancer biology research because his mother died of cancer. It's the entire reason he got into it. And you're telling me there's an amount of money that you could pay that guy to be quiet about a cure for cancer? I'm sorry, I just don't buy it. So the point is, you can fool some of the people some of the time, but you can't fool all of the people all of the time. And when it comes to scientific research, that's why replication is the mother of all science. So that is why we're not just going to talk about single studies, but we're going to talk a lot about meta-analyses and groups of studies. So without further ado, let's get into sugar and why I don't believe it caused the obesity crisis. I know it's probably tedious to hear a lot of that backstory, but I think it's very important to go through it to set you up so that you can have some trust in data. Because what I tend to find is when I present data that is in opposition to what people already believe to be true, they just go, well, I don't trust scientific research because all of it's bought and paid for. Except the research that supports their bias, which apparently is beyond a reproach. It always is the logically inconsistent thing that I hear over and over and over. So I've done my best to set you up to understand why you can trust scientific research, because the scientific method is perfect, even though people who do science are not. And that is why replication is the mother of all science. Okay, sugar. My personal background is when I got to graduate school, in circa 2004, I believed that sugar was uniquely fattening beyond the calories it contained. I got to be very specific about this. So I believed sugar was independently fattening, meaning if you gave 100 calories from sugar, I did not believe that the same thing would happen if you give 100 calories from fat or other carbohydrate. I believed that sugar was uniquely fattening beyond the calories it contained. But before we get into why I believe that, let's talk about what sugar is. So typically when you're talking about sugar, you're talking about monosaccharides and disaccharides. Now, monosaccharides are mono, one sugar. So one ringed sugar. Most of these monosaccharides are in a hexose shape, meaning they got like 6 sides to them. There is fructose, which is a pentose, which is a pentagon, so 5 sides to it, to the molecule. But they all have kind of similar structures. And monosaccharides would be things like glucose, galactose, and fructose. Disaccharides are two sugars linked together. And those are things like sucrose, which is table sugar, which is glucose and fructose linked together. So one glucose molecule, one fructose molecule. Lactose, which is glucose and galactose linked together. Maltose, which is 2 glucose molecules linked together. But most people, when they're talking about added sugar or they're talking about table sugar, they are talking about sucrose. So a lot of what we're going to talk about here is going to be focused on sucrose, but then also high fructose corn syrup. Okay, that is something that strikes fear into the heart of a lot of health advocates. High fructose corn syrup is not very different from sucrose in terms of its chemical composition. It is about 45% glucose and about 55% fructose. Now, why do they do it that way? Fructose is a little bit sweeter than glucose. So by adding fructose to the mix, you can make something sweeter. So high fructose corn syrup is used in a lot of ultra-processed foods because it tastes very sweet. It is used in sugar-sweetened beverages like Coke, Pepsi, your soft drinks, or depending on what area of the country you're from, you might say soda or pop, or just say Coke. I'm from a place where we call it a soft drink. I'm from the Midwest. So I'll probably refer to it as, I'm a scientist, so I'll refer to it as sugar-sweetened beverages. But where I came from, we've talked about it as soft drinks. High fructose corn syrup was even a level above or below, depending on how you look at it, sucrose in terms of what I believe to be bad for you. I thought high fructose corn syrup was like the most fattening thing that you could possibly take in, and I avoided it like the plague when I was getting to grad school. And the reason I believe this was because it was higher in fructose. I thought fructose in particular was bad for you. And I actually stopped eating fruit, really. I kind of avoided fruit for like 5 years because of fructose. Now, why was I avoiding fructose? Well, one, fructose isn't a good source of muscle glycogen replenishment. So when you resistance train, you exercise, you break down stored glucose, which is called glycogen, in your muscles to help fuel that exercise. And a lot of athletes focus on glycogen replenishment. And fructose is not really a great source of muscle glycogen replenishment because the enzyme that will convert fructose into glucose and glycogen is not really present much in skeletal muscle. It's present in liver, and so you can convert fructose to glucose in the liver pretty readily, but not so much in muscle tissue. So that was one ding against it because I was very focused on my muscle glycogen. The next thing, and probably more importantly, was there was mechanistic data, demonstrating that if you fed fructose, you could increase what's called de novo lipogenesis. Now, de novo lipogenesis is the formation of fats from non-fat substrates. And fructose appeared to have a unique effect on de novo lipogenesis. So that was another ding against it because I don't want to be making fat out of nothing. The next thing was fructose doesn't really increase leptin. Now, we'll do another show on leptin, but leptin is from I think it's Latin or Greek word leptos. I can't remember if it's Latin or Greek. Leptos, meaning thin. When they discovered the gene for leptin in 1996, they believed they had solved the obesity crisis. they found if they knocked the gene that made leptin out of mice, these mice got enormous. And then if they injected them with leptin regularly, they got back to normal size. And even more interestingly, if you knocked out the leptin receptor, then these mice, again, got enormous. But then if you injected them with leptin, nothing happened because they didn't have the receptor to actually be able to use the leptin. So what does leptin do? Well, you can think about leptin as kind of your master appetite regulation hormone, as well as possibly there's some evidence that it may regulate energy expenditure as well. But if your level of body fat rises, if you put on more body fat, your fat cells expand and secrete more leptin. So leptin is made in your adipose tissue. You secrete more leptin. That leptin goes to your hindbrain and tells you, hey, we're not hungry. So it helps with your appetite regulation. Then, as you lose fat and those fat cells shrink, you secrete less leptin, you get more hungry. So it's almost like a thermostat for your body fat. And if you've ever heard of the term body fat set point or settling point, a lot of it is explained by leptin. And they've done these experiments in rodents where they would knock out leptin, animals get fat, infuse leptin, animals get thin. And it was very reliable. Interestingly, in obese people, they actually have high levels of leptin. They just become very insensitive to leptin. And that is because leptin and insulin tend to go hand in hand. So as you increase fat cell size, you increase your secretion of leptin and insulin, but your body gets less sensitive to their effects. Your brain and your muscles get less sensitive to their effects. As you lose body fat, you secrete less leptin and insulin, but you get more sensitive to them. And insulin is involved in the secretion of leptin. So there's something called the hexosamine pathway where if you give glucose in particular will reliably increase leptin. So if you give glucose, it increases insulin goes up, leptin goes up. So I am very, very much abridging that entire process, but just trying to give you the idea that typically leptin and insulin kind of go hand in hand. And at the time, I was very focused on leptin because it was very new and sexy, and I thought it was awesome. And it is awesome, but we have learned that leptin was not the cure for the obesity epidemic because we gave obese people leptin and it didn't do anything because they're leptin insensitive. What leptin did seem to do in terms of if you infuse it or inject it is people who lose a good bit of weight, if you give them leptin after they've lost weight, they keep it off much more reliably than people who don't get it. And that is because once they have lost weight, they become more leptin sensitive, but they have less leptin. So if you infuse it or you give it injectably, then it can have an effect on appetite and people can keep weight off better. Now, again, it is not really a solution for the obesity crisis. It is very expensive to make, at least last time I checked. And now we have things like GLP-1 mimetics, which are much, much more effective and reliable. But again, at the time, I wanted to get as much leptin as I could because in my mind, okay, if I have to pick between glucose and fructose or starchy carbohydrates versus fructose-containing carbohydrates, if I'm going to eat carbs, if I'm going to eat like 100 grams of carbs at a meal or something like that, I want to get the most leptin out of that meal I possibly can because that's going to tell me I'm full and it is going to increase my energy expenditure and help me get jacked and shredded. So that was another strike against fructose for me. And then I was also influenced by books written by Gary Taubes, which claimed that sugar and in particular refined carbohydrates were the cause of obesity. I think his first one was good calories, bad calories. So I actually read some of this and it influenced me, even though now, if you followed me for the last 10 years, I go after Gary Taubes quite frequently. Probably some ire about being misled when I was younger. And Gary believes in a theory of obesity called the carbohydrate insulin model of obesity, which I will summarize very briefly. Hey guys, Lane here. And if you listen to my podcast, you probably love my research breakdowns. I don't put in a bunch of unnecessary fluff and scientific mumbo jumbo. I just give you the straight facts, but keep the nuance. And so if you love my research breakdowns, you'll love my research review reps. Research explained with practical summaries. Every month, My team of experts breaks down 5 studies in nutrition and fitness in a way that is palatable and easy to understand, even if you don't have a scientific degree. We tell you what the researchers tested, how they tested it, what they found, and what it means for you. And if we disagree with the researchers' conclusions based on their own data, we'll also tell you that. There's no BS, there's no fluff. We give you the straight facts. So if you're looking to up-level your brain and body gains, click the link in the show notes. Most evidence-based scientists believe in the energy balance model of obesity, which is if you consume more calories than you expend over a 24-hour period, and you do that repeatedly over months and years, you will put on body fat because you will be in an energy surplus. So because you're consuming more calories than you burn, you will add body fat. The carbohydrate insulin model of obesity goes something like this. You don't get fat because you overeat calories. You get fat because you consume refined carbohydrates or sugar. That increases insulin. Insulin inhibits lipolysis, which is the breakdown of fatty acids from adipose tissue. That traps fat in fat cells, and it makes it inaccessible for the rest of the body because your body fat stores, your adipose tissue, are basically your energy reserves. If you're inhibiting lipolysis, you are not able to access that form of stored energy. The body, the rest of your body, doesn't have access to that energy. And so you feel hungry and you overeat in response to that because your body thinks it's starving, and you become fat because of that. If I had to summarize it in a line, I would say that the carbohydrate insulin model of obesity says that we don't get fat because we overeat. We get fat because we consume refined carbohydrate and we overeat in response to it. So it's basically a chicken versus the egg argument. All of those reasons were strikes against fructose, high fructose corn syrup, and sucrose, these fructose-containing sugars. I didn't really believe that glucose was a big problem. I didn't really try to consume a bunch of it unless it was immediately after my workout, in which case it was okay to consume tons of glucose based on bodybuilding lore back in the early 2000s. And I'm not going to touch on why that was the case, but I specifically was trying to avoid refined sugar and fructose. So now that we've gotten that preamble out of the way, let's go through the evidence in support of sugar causing the obesity epidemic. So obesity is a relatively new disease. Yes, you had obese people, back in the 16, 17, 1800s, but really it was kind of a disease of opulence. In fact, in a lot of cultures, if you had more body fat, it was viewed as desirable because it meant you had access to a lot of food, and by default, wealth. So from 1900 to like 1970-ish, obesity went from basically almost non-existent, less than 5% of the population, up to like around 10%. Pretty steady rise. And that was correlated with the rise in sugar consumption. And then around 1950, we had a pretty big spike that started in sugar consumption all the way up into the year 2000. And that spike was associated also with a spike in obesity. So we went from around 10% of the population being obese in like 1970 to almost 45% in the year 2000. Pretty rapid increase in obesity over about a 30-year period. And again, this correlated well with the rise in sugar intake, most of which was from sugar-sweetened beverages. These were not people eating too many grapes, Dr. Gundry. These were not people who could not stop eating bananas. These were people who were consuming typically large amounts of sugar from sugar-sweetened beverages and other ultra-processed foods. Then we also had animal models that demonstrated very high intakes of sugar, and in particular fructose, increased fat deposition kind of beyond what you would expect for the amount of calories they contained. And fructose had its unique effect on de novo lipogenesis as well as liver metabolism. And some people speculated that fructose could be to blame for non-alcoholic fatty liver disease, because we saw in people with high sugar consumption and excess body fat that many of them developed non-alcoholic fatty liver disease. So all this is stacked in the corner of sugars causing obesity. And this was my viewpoint up until about, I would say, like 2004-ish, 2005. And the first thing that got me thinking about this differently is I can remember very clearly being at a graduate school mixer for new grad students. And so everybody's like having beers and wine and cocktails, and I'm bodybuilding lane at the time, so I'm drinking my gallon jug of water and talking to people. I didn't drink, so that was my conversation starter at the time, was a gallon jug, which looking back, cringe. Anyways, I overheard Manny Nakamura, who his office was literally right across the hallway from where the lab I was working in. And Dr. Nakamura was talking to another, I can't remember if it was a professor, a postdoc, or a graduate student about fructose and high fructose corn syrup. And Dr. Nakamura had done some of the research studies demonstrating for fructose and high fructose corn syrup to have unique fattening effects. And this other person was asking Dr. Nakamura about fructose and high fructose corn syrup. And I remember thinking, well, okay, well, he's going to say that it's like the worst thing in the world. And he said, yeah, we were able to show this in a rodent model, but we fed just a completely ridiculous amount of fructose that you could never get through the human diet. And we're pretty sure it's just a calorie effect. It was cool of us to show the mechanism existed, but I'm not sure how much it actually contributes in humans. And I'm like, what? You're not supposed to say that. So I was very shocked by this, but it got me thinking. I'd never really looked into the research on sugar. And I did think about, well, I do have a lot of glucose after a workout, and I haven't gotten fat from that. I mean, because I'm watching my macros and my calories. So I thought, okay, well, maybe I can, I still was worried about fructose. But I'm thinking, well, sucrose, it's half glucose, half fructose. If I have a little bit of it, not a big deal. Maybe some fruit. And this gene runs in my family. On my mom's side is where the gene comes from for sure. Because my grandmother, my mom, myself, and my daughter, we all love ice cream. If you could give me one thing to eat for the rest of my life, just purely based on taste alone, I'm going with cookies and cream ice cream. Y'all can argue with me. You're wrong. It's okay. We all have our days. But that's it for me. And I love ice cream sandwiches as well. It's one of my favorite treats. And I was just like, these ice cream sandwiches are like 25 grams of carbohydrate, like 10 to 15 grams of sugar, I think. I'm like, I'll just have one like during a contest prep, just like one a day. And I did in bodybuilding shows, and I won. I still got really lean because I was tracking my macros and eating in a calorie deficit. And then I started looking at more research, and I became pretty convinced that it wasn't really a big deal. And so for my shows in 2010, I stopped worrying about sugar. I just didn't worry about it at all. I ate the foods I liked, still getting enough fruits and vegetables in. I did eat quite a bit of fruit. I did still have like one serving of ice cream a day, getting ready for my pro shows in natural bodybuilding. And my average sugar intake was probably anywhere from 50 to 100 grams a day between the fruit I was eating and some of the treats I was eating. I ate a lot of strawberries too. And I got the leanest I've ever been on 50 to 100 grams of sugar every day. Now, I'm still getting enough fiber and protein, which is the important stuff. But like I won a pro bodybuilding show having an ice cream sandwich or a bowl of ice cream every single day. And at night too. Oh my gosh, carbs at night, sugar at night. So I really started thinking about this, and I started kind of talking about it more, and people would get so angry with me. So I really started digging into the research literature because, I like to be right. I'm okay with being wrong, but I like to be right like anybody. And so I wanted to see, well, what did the research say? Like, is my experience actually legit, or are there studies in humans showing uniquely fattening effects of sugar and fructose when you're accounting for the calories? Because a lot of the original studies were correlation studies where they say, well, people who eat more sugar tend to have more body fat. Put that in the duh column. Or it was studies where they would give different diets, but they wouldn't control the calories. And so you didn't know if it was because people were overeating the sugar or overeating calories in general is why they were getting fat. So I really wanted to dig into this. I started thinking also about the fact that, okay, if I eat starchy carbohydrates, or if I eat any source of carbohydrates, it all gets broken down into the monosaccharides anyway. Like it all gets chopped up during digestion. So like it's going to wind up in your bloodstream as the same thing. So why would this matter? Now, some people would tell you it matters because of glycemic index, which glycemic index is kind of measuring the rate of appearance of glucose in the bloodstream. And I'll come back to GI. We'll talk about that later. But what was weird is fructose is actually pretty low GI because it doesn't really impact blood sugar that much. And so there was a time where people thought fructose was actually a good sweetener because it didn't impact blood glucose. But really, the true test of things is if we vary the amount of sugar in the diet, or we vary the glycemic index of the diet, does that actually make a difference on fat gain or loss? And the answer, through the research I have read over the last 2 decades now, is an absolutely resounding no. And I will go through this research with a fine-tooth comb with you. So first, let's look at a meta-analysis of 68 studies where they examined diet sugars and their impact on body weight when being exchanged isocalorically for other non-sugar carbohydrates. So when I say isocalorically, that means if maybe one study say, okay, we're going to have, this group's going to get 50 grams of sugar. The other group, we're taking out that 50 grams of sugar, but they're getting 50 grams of another source of carbohydrate, non-sugar carbohydrate. But we are keeping the calories in the diets the same. That is the important point. That is the point we have to hit home with. If we control total calories, do people eating higher sugar gain more body fat or lose less fat in a fat loss diet than people who eat less sugar? And this study, this meta-analysis of 68 feeding studies, showed no difference in body weight when you isocalorically exchange sugar for non-sugar carbohydrate. I'll say it again. 68 studies, the summation of which showed no difference between low sugar and high sugar when you controlled for calories. There's also studies that looked at exchanging fructose for glucose, fructose for sucrose, glucose for sucrose. When they were exchanged isocalorically, no difference in body weight. And these results held for non-type 2 diabetics and type 2 diabetics. Because a lot of people will go, oh, that's great for fit people, Lane, but what about people with type 2 diabetes? They can't have sugar. Well, again, in these studies where they control calorie intake and equate it between different treatments, sugar does not seem to affect body weight, even in people with type 2 diabetes who have poor insulin sensitivity and are metabolically unhealthy. There's also no effect of fructose on body weight in controlled feeding trials where it's exchanged one-to-one with other carbohydrates. Fructose, the one that is the worst, doesn't replenish muscle glycogen, doesn't increase leptin, increases de novo lipogenesis, and has unique effects on liver metabolism. When you exchange it 1-1 with other dietary carbohydrate, there is no effect on body weight. You can speculate about mechanisms all you want. You can show a lot of cool mechanisms in animal studies, but so much gets washed out in actual outcomes, because outcomes are not singular mechanisms. Outcomes are the summation of dozens, if not hundreds, if not thousands of biochemical pathways, all summing up to an outcome. And so, again, it is possible that any nutrient you eat can positively and negatively affect pathways, both summing up to an outcome. The question is not whether or not it negatively and positively affects different pathways. The question is, what is the overall outcome? Much like if I have a mutual fund of 100 stocks and I tell you, hey, be careful, 3 of these stocks are down by 30%, and you go, oh, and I neglect to tell you that overall the mutual fund is up 20%. What do you care more about? That there's 3 stocks inside that mutual fund that aren't doing well, or that overall the mutual fund is killing it? You care that overall the mutual fund is killing it. Now, some people will say, oh, well, it's actually carbohydrates themselves. Carbohydrates are bad because they turn into sugar in the body. Well, they also showed then when you exchange sugar isocalorically with fat, that it doesn't affect body weight. So again, equal calories, eating more fat or less fat, more sugar or less sugar, no effect on body weight when you control calories. Now, I know I talked about individual studies versus meta-analyses, and I have been citing thus far mostly meta-analyses because they are a bunch of studies into one study. They are compounding these studies to form a consensus. They're looking at the overall outcome. But there is one study that I thought was really cool, and I cite it frequently. Very classic study, in my opinion, by Surwitt et al. In 1997. They took people and they put them on diets that were equal in calories. And what was nice about the study is they provided all the food to participants. There was very, very high adherence levels, very high. Each person in the study had the same level of calories, had the same amount of protein, same amount of carbs, same amount of fats. One group was eating over 100 grams of sucrose per day. Another group was eating around 10. Now, they were both on 1,100 calorie diets. Both groups lost weight, both groups lost fat, and they lost virtually identical amounts of body fat. And they both improved virtually all their markers of metabolic health. The only small difference was a very, very small difference in LDL cholesterol, in which the low sugar group had a little bit better improvement in LDL cholesterol. The high sugar group still improved their LDL cholesterol, but the low sugar group improved it a little bit more. But this was probably because they got more dietary fiber, and dietary fiber has been shown to lower LDL cholesterol. So this wasn't a low sugar effect. This was a high fiber effect, in my opinion. And we have seen this anecdotally with Dr. Mark Haub. He became known as the Twinkie diet professor because he asked his students, what's more important, the number of calories I eat or the type of foods I choose? And most of his students said the types of foods. And so he said, okay, I'm going to do I think it was an 1,800 calorie diet, and he called it originally the 7-Eleven diet. So it wasn't just him eating Twinkies. He basically said, I'm going to get 1,800 calories, all from ultra-processed foods. If I can't buy it at 7-Eleven, I'm not eating it. So everything he ate came in a package. I believe he supplemented with a protein shake and supplemented with a multivitamin. That was it. And he lost 27 pounds, I think over the course of 12 weeks, and basically all of his markers of metabolic health improved. Now, Mark will tell you that by the end, he wasn't a big fan of the diet because he was hungry, because it wasn't eating much fiber, and the diet wasn't very filling. And he said, I'd like to just had a big salad or something like that. But it didn't stop him from losing a lot of weight in a pretty short period of time. I mean, he was losing over 2 pounds a week because he was eating 1,800 calories a day. And it was funny when Mark would give presentations, he was telling me how he used to pull up tables of his nutrient intakes and say, does this look like a healthy diet? And he'd say, some people would be like, you're a little bit low in vitamin K, but yeah, this looks healthy. This is a healthy diet based on your nutrient intakes. And then he would pull up a slide of the foods he was eating and say, does this look like a healthy diet? And people go, no. He goes, what if I told you these were the same thing? So again, there's an anecdote to support it. And even like way back in 1975, there was something called the white rice, I think it was the white rice and juice diet. And there was actually a study on it. They had people eat, it was a low calorie diet, I think around 1,000 to 1,200 calories a day, I believe. And the main sources of food were white rice, grape juice, and sugar, like sugar-containing foods. And the average weight loss in the study, this was people with a lot of obesity. I think the average weight loss was something like 130 pounds or something like that. And so if sugar is uniquely fattening, especially based on the carbohydrate insulin model of obesity, I mean, those results should be impossible. They should not be able to exist. Now, what about high fructose corn syrup? We've been talking about fructose. We've been talking about glucose. We're talking about sucrose, sugar in general, carbohydrates. What about high fructose corn syrup? Because hopefully by now, I'm pretty well established that sugar is not uniquely fattening. But what about the evil high fructose corn syrup? Is it uniquely fattening compared to other sugars? And a meta-analysis looking at exchanging high fructose corn syrup, glucose, or sucrose showed no difference in body weight. Even the evil high fructose corn syrup didn't do it. Again, when you equate calories, the sugar content just doesn't seem to matter. You've probably heard me talk about my app, Carbon Diet Coach. That is because it is the best damn macro tracking and nutrition coaching app on the market. I use it, and so should you. I have packed all of my one-on-one nutrition coaching experience and my PhD knowledge into one simple app that will help you build muscle, lose fat, all for just a few dollars a week. It's so simple how it works. All you got to do is track your macros, weigh in regularly, and then check in every week, and our customized nutrition coaching algorithm will give you personalized macronutrient adjustments tailored to your goals and individual metabolism. No fad diets, no BS, just simple science that is guaranteed to work. Millions of pounds of fat have been lost and thousands of lives have been changed with Carbon. So what are you waiting for? Go to joincarbon.com/podcast to take the guesswork out of your diet. Okay, so hopefully we've established that sugar is not uniquely fattening. But I know what the next response is going to be. But Lane, that's just body composition. That's just aesthetics. What about overall health? What about metabolic health? I'm so glad you asked, because that was what I thought too when I first started looking into this stuff. Surely this has to make a difference in metabolic health. Like, there has to be a difference here. And again, we have several meta-analyses that demonstrated when you exchange high fructose corn syrup, sucrose, fructose, you don't see an effect on cardiovascular disease risk factors, glycemic control, blood lipids, cancer, or pretty much any marker of metabolic health. And even fructose, when you exchange it isocalorically with other carbohydrate, you don't see a difference in liver fat accumulation, which that was supposed to be the one thing. Robert Lustig talks about this all the time, that fructose is fattening for the liver. And yet, in studies where they equate calories and exchange it with other carbohydrate or other sugars, you don't see an effect. Now, what about glycemic index? The glycemic index, or GI, refers to what is the area under the curve after you eat 50 grams of carbohydrate from a particular carbohydrate source. The scale is 0 to 100, 0 being no response whatsoever, 100 being, well, it's not the most you can get, but it's based on what is the response to glucose. So 50 grams of glucose is a score of 100 on the GI scale. Now, there are some carbohydrates like maltodextrin, which I think is rated at like 110, that can get higher than 100. But essentially, the lower the number, the less glucose response under the curve over 2 hours. So things like white bread are 75, potatoes, like white potatoes, are somewhere in the 70 range. Ice cream is like a 60, moderately GI. And then a lot of vegetables are like under 20. So very, very little glycemic response. The limitations of glycemic index are that it's only looking at the carbohydrate source in isolation. When you have a mixed meal, a lot of the effect of the GI gets washed out or blunted out. Protein, fiber, those things kind of blunt the blood glucose response to a meal. And all that being said, the glycemic index of food does not appear to impact weight loss, cardiovascular disease risk, or diabetes risk. And in controlled feeding trials, you don't see a difference in body weight or weight loss when calories are equated between diets and they vary the glycemic index. Sugar table sugar, glucose, fructose, high fructose corn syrup, glycemic index, doesn't seem to make a difference when it comes to body weight when you are controlling overall calories. Now here's the kicker. I showed you that chart of sugar intake earlier, and it showed, from 1970 to, 2000, obesity went up in tandem with an increase in sugar intake. What I didn't show you was the next 20 years, where sugar intake went down and obesity continued to climb. So in fact, sugar intake, particularly from sugar-sweetened beverages, has declined over the last 20 years while obesity has continued to rise. So as you can see here, sugar intake peaked out just before the year 2000, and it has now fallen back to around levels that you would see in the early 80s. Even though obesity rate has continued to climb at pretty much a linear clip. Again, this does not jive with sugar being an independent driver of obesity. Now you see the chart, you see them diverge. What explains it? Well, even though sugar intake has gone down, we have still continued to increase our calorie intake and our intake of added fats. But wait, there's more. There are many populations around the world that are lean despite eating diets high in sugar. The Hadza are an example. They eat pretty much the same amount of sugar as people in the US, but they are not obese. Now, most of it's from honey. And I know people will say, well, that's natural sugar. Okay, but chemically speaking, they are the same nutrients. They look the same. When they get in your body, they are the same. The Mbuti pygmies get up to 80% of their calories from honey at certain times of the year. They aren't obese. Now again, people will say, it's natural sugar. That's fine. Okay, well then let's look at the Kuna of Panama. They get about 17% of their total energy, which is around the same consumption as in the US, from sugar, most of which is refined because there are trade routes open there where they get access to refined table sugar. So they're eating pretty much the same amount of table sugar as we are, and they're still not obese. They're actually lean. Okay, so controlled feeding trials, this stuff doesn't seem to make a difference. Like, it really doesn't. I know a lot of people get mad at me about that, but it just doesn't make a difference even if you're type 2 diabetic. Now, what about sugar addiction? Because some people have said, okay, they recognize that calories are important and that, yes, sugar is not an independent driver of obesity, but sugar is addictive. And then you eat too much, you eat too many calories. So it's still, I'm just playing semantics, basically, these people would say. Well, there's really very little evidence to support sugar addiction in humans, but there is some evidence for what's called a food dependence. But most of these foods are, yes, high in sugar, but also high in fat and have particular like mouthfeel and texture to them. What makes a food hyperpalatable is not just the sugar content. If it was, we would go to bags of table sugar and just down those. If bags of table sugar were as palatable and addictive as cookies, cakes, ice cream, snack foods, if it was, I would just keep bags of sugar in my house, or people would just keep bags of sugar in their house because it'd be far more cost effective. If it tasted as good as like an Oreo, you would just eat the sugar if it tasted just as good. But it doesn't, because it doesn't have the same texture. It doesn't have the same mouthfeel, because fat also adds flavor. And then the processing of the food also adds mouthfeel, texture. All this stuff matters. So yes, there are particular foods that people may develop a food dependence with, but it's not the sugar that's making them addictive. It is the overall milieu of the food, which can include sugar. But sugar itself is not what people get addicted to or dependent on. Now, I want to be clear here, because there are some people who will probably splice these clips up and say I'm a sugar shill, or that, I'm making certain claims about sugar that I am not. So let's talk about what I am not saying. So here are things I'm not saying about sugar. I am not saying sugar is good for you. I am not saying you should eat sugar. I am not saying sugar is good for weight loss. I am not saying any of those things. I am simply saying that when you control overall calories, sugar appears to be about as bad for you as excess calories from most any other source other than perhaps protein and dietary fiber. And that leads me to my next point, which is if you want to focus on the big rocks like we talk about in the show, focus on your total energy intake, don't eat too much, your protein intake to support lean mass and energy expenditure, and your fiber to support overall health and satiety. Those are the biggest drivers for body composition and metabolic health. Everything else is very far down the list. Some people won't like that, but it is the reality of what the data says. In fact, I became very convinced around the end of my graduate school that the negative effects of high sugar diets were actually more so negative effects from low fiber intake, because people who eat high sugar tend to eat low fiber. So, eat your protein, eat your fiber, lift the weights, be active, and don't eat too much. And if you do those things, you are ahead of 99% of the population. Now, if you want to go even deeper on this and see even more references, you can check out my article in the show notes called Why Sugar Did Not Cause the Obesity Epidemic. I'd also really appreciate it if you left my podcast a 5-star review on whatever platform that you listen on. It helps us get rated. And if you'd be so kind to leave your feedback, I would really appreciate it. Even if this podcast really pissed you off because you hate sugar, don't hate me, hate the data, because data is more important than feelings. And again, I want to really emphasize the fact that I believed that sugar was bad for you when I went into this. I did. And my research was funded by lobbying companies that were in opposition to sugar. I came from a lab that was known as a lower carb lab. My background is not as a friend of sugar. Now, I've had people say, well, you were sponsored by Monster Energy Drink. I wasn't ever formally sponsored by Monster, I don't think anyway, but they used to send me a lot of cases of Monster because I love white Monster. And they're owned by Coca-Cola. And people are like, oh, you drink Diet Coke all the time. And you're funded by Coke. I've never gotten money from Coca-Cola. I mean, I wish I was on that payroll. That would be nice. But the data is what the data is. I'm not promoting sugar intake. I think sugar-sweetened beverages are a really bad idea. And oh, by the way, the last time I had a regular soda or had a sugar-sweetened beverage, gosh, other than like maybe having a sip of one here or there because I was really thirsty and didn't have access to anything else, I think the last time I had one was probably in high school, to be honest with you. It's been a long, long time. And the Monsters I drank that I loved, that I get cases of, they were sugar-free. So how am I in the pocket of big sugar? Anyways, it's ridiculous that I have to talk about this stuff, but I know what the criticisms of this podcast are going to be, and so I feel like I need to cover them. So there it is. There's the data. I am not trying to say that sugar is good for you. As a general guideline, I think trying to avoid added sugar is a really good guideline, because most people, if they have a Coke, they're not going, well, that was 50 grams of high fructose corn syrup or sugar, so therefore I am going to not have pasta tonight and reduce my carbohydrate intake by 50 grams. But people don't do that. They just eat whatever they normally eat and drink a Coke on top of it. So I think from that perspective, from a free living, real world perspective, it absolutely makes sense to try to limit your intake of sugar. But use it as a guideline, not as a rule. Because when it's a rule, it makes people do really dumb things like me, like avoid fruit because I was scared of the sugar in it. Be like the Hadza. Don't fear sugar if it's from fruit. It has a bunch of health benefits. Fruits and veggies. Eat them, kiddos. All right, guys. Hope you enjoyed the episode. I will catch you next time. And again, if you leave us a review, I'd really appreciate it. Catch you next time.